So here are the recorded temperatures at 3 different times on a winter evening. Tyler says the temperature dropped faster between 4 p.m. and 6 p.m. May says the temperature dropped faster between 6 p.m. and 10 p.m. You're deciding who you agree with. Some of you were talking still, so I had a feeling you didn't even read it. So maybe if I read it to you, you'll come to a decision. You have like 30 seconds before we vote. Raise your hand if you agree with Tyler when he says that the temperature dropped faster between 4 p.m. and 6 p.m. Okay. Avery, why? Why do we agree with Tyler? Okay. Jake, what's your reasoning? Okay. I dropped more. What was that last part? Is that it? It just dropped more? Okay. Anyone else? Tristan?
It dropped more in less time.
All right. Anyone have a different way of saying it? Those of you that picked Tyler, Aiden. Where do you see it graph? Okay, so the table's going down at a constant or at a continuously going down. So you think that it just dropped more between this pattern? Okay, anyone else? Braden, do you have anything to add about why Tyler is right?
I said from 4 to 6, it dropped 8 degrees, and then 6 to 10, it dropped 9 degrees.
Okay, dropped 8, whereas here it dropped 9. So, anything else anyone wants to add that wasn't Tyler? So, I mean, 9 is bigger than 8, but the whole key there that Kristen mentioned is like it dropped more in less time. Whereas this was in 4 hours that it dropped 9 degrees, it dropped 8 degrees in just 2 hours. So comparatively speaking, that is why we're saying that Tyler is right. Who wants to give a reason that May is right? I'm not saying which is right or wrong yet. We'll find out later. But anyone have a good support for May? There's about half of you that didn't raise your hand. Or are we convinced otherwise now? Do we all think Tyler's right now? So I'm not supposed to tell you the answers yet. You'll see when we do the next activity, which is still related to what's going on in the warm-up. But so far we just have justifications for why Tyler's right, and no one wanted to give a justification. So we'll see. But today the goal is to measure how quickly the output of a function changes. By the end of the lesson, you need to understand the meaning of the term average rate of change, and when given a graph of a function, can estimate or calculate the average rate of change. I'm recording right now. I recorded today. Practice is in Schoology, and we don't have any more assessments before break, just after break. And this will be the week after Thanksgiving break. So you'll have a quiz, you'll have your minor check, and also the deadlines for late work is that Friday. And typically, like when the test falls the next week, typically I extend the deadline through Monday at least, but we are toward the end of the semester. Like I can't keep letting you turn things in late in December. All right, so make sure that we're staying on top of it. I really don't need you doing the practices after the unit test, like they are pointless. They really are. They affect your grade this much, like for that one homework assignment, but you see the results in your grade when you take the test. So if you're doing them after the test, like completely meaningless. That's why I disabled the submissions afterwards. So keep that in mind. Use this break that you have a whole week of to catch up if you're behind. Make sure that you have all your notes through lesson 7. I even made all of the study guides visible, and you can start working on them over break if you get bored. Honestly, like after today, we are more than halfway through the units. We have like 4 lessons after that, and then there's already study guide time and report test time. All right, but there's that. Any questions on anything I said? No. All right, so we are practicing average rate of change, which should sound familiar. Anyone know what else we've called average rate of change before?
Slope.
Slope, good. Slope is specific though to just linear functions like straight lines. And we know that with linear functions, the slope is the same no matter where you are moving. Because those go up and down at a constant rate. We are now looking at graphs of all sorts of shapes, like in this real world situation. So the process of finding your average rate of change is honestly exactly the same. We even use the exact same formula. It just so now happens that you have to pay attention to where they want you to look. Because my rate of change from here to here is not necessarily going to be the same as from here to here. All right, so at least now that's the plus side of it, is that in whatever problem you are doing that says to find average rate of change, it'll always tell you where it wants you to look. So like how in unit 3, you had to pick 2 coordinates and it could vary. Now you have to pick the 2 they say. Otherwise the average rate of change will vary depending on where you're looking. So average rate of change formula, write this down somewhere, probably under the warm-up because we will have more room there. But whenever it asks you the average rate of change, and it'll come up on every test moving forward, and these are other grades too, that is found by doing y2 minus y1 over x2 minus x1. I could put the definition in function notation, but like, I want you to see it's literally how you find the slope. It's the same formula I had you memorize last time. So for every average rate of change problem, I need to identify the 2 points it wants me to use. Make one of them x1, y1, the other x2, y2, and plug it into that formula. All right, so here's the situation. The table and graphs show a more complete picture of the temperature changes on the same winter day, as in from Pomona. The function T gives the temperature in degrees Fahrenheit, H hours since noon. We're going to find the average rate of change for the following intervals. Let's do 1A together, and then you'll try these other ones. So think about it, don't say it. Think about what points I need for this time frame. For this formula, I need 2 coordinates. If I want to find it between noon and 1 p.m., think about what coordinates I need. Say it. All right, table 4. What point, and you could do it from the graph or from the table, but what point would represent noon exactly? Okay, so you think that noon is 4 hours since noon? So go back and read the situation, and remember, we've been spending a lot of time like interpreting situations, like figuring out what's your input and what's your output. It says the function T gives a temperature in degrees Fahrenheit each hour since noon. So if it wants me to find the average rate of change between noon and 1 p.m., I need to know what coordinate would represent noon. 0, 18, because H is hours since noon, right? And T is that temperature. Here's my input output, which can be written as a coordinate. Now, table 5, what about for 1 p.m.? What coordinate represents 1 p.m.? 190, good. Right, because 1 p.m. would be 1 hour since. I know on your homework the other day, it was a problem similar, but it said hours since midnight, and then we were talking about 1 p.m. That would be 13 hours since midnight, right? But we're talking about hours since noon, since 12 p.m. Questions on how we pick those random? So once you have the coordinates you need, label one of them as x1, y1, the other as x2, y2, and plug it into your average rate of change formula. I would copy this down every time until I memorized it. That's what I recommend you guys do. But label them, plug them in. The way that I labeled it, it would be 19 minus 18 over 1 minus 0. Okay. Y2 minus y1 over x2 minus x2. And then you can use a calculator to simplify that, but the number is not too bad. What's 19 minus 18? What's 1 minus 0? So that is what it changed on average. It changed 1 degree Fahrenheit, so it's still like rise over run. You could still express units. It changed 1 degree Fahrenheit for every 1 hour. That's new. Obviously, like, I mean, that was 1 hour difference, so obviously it changed, but that's just our first segment. All right, does that make sense? Okay. So you are finding the average rate of change for the rest. I know I left it as a fraction to show you the units, but really, like, you could just say the average rate of change is 1, or whatever decimal the fraction. So the average rate of change for 1A is 1. Find the average rate of change for the other 2. And then I'm going to be calling on people to give me what coordinate I need, to tell me what my y2 is if I label it like that, and blah, blah, blah. So make sure that we are actually trying and understanding what's going on. If not, you need to ask. It's a super important skill. Table 6, what coordinate would be noon? If it wants us to find from noon and 4 p.m. the average rate of change, what coordinates do I need? Okay, great. Moving forward, it's going to tell you what it wants you to find the average rate of change of, and you need to pick the right coordinates that go with that. If it's a graph, estimate the graph coordinates. Luckily, we have a table, so we know what they are exactly. Sometimes they also just give you equations in function notation and say, find it from when x is 0 to when x is 4. Then you have to plug it in and get those outputs. So be able to do that no matter how it's given to you, you know you need to plug it into this formula, so you need 2 coordinates. Once you have your 2, label one of them x1, y1. I'm going to do it a little differently because I have a feeling you guys label this one x1, y1. I'm just going to show you that it doesn't matter. So long as you're not making a X value a Y or something weird like that. But then you're plugging it into this formula. So the way that I labeled it, it would be 18 minus 25 over 0 minus 4. Class, what's 18 minus 25? -7. And what's 0 minus 4? Which it's probably better to use the decimal. I mean, sometimes they want you to leave it as a fraction, but first of all, it will be more positive because it's negative. And that decimal is 1.75. All right, so since it's positive, does that mean that the temperature increase or decrease by that amount? That's my average rate of change. So if it's positive, did it increase or decrease by that amount? It increased by an average of 1.75 degrees Fahrenheit for every 1 hour. Because really, like, even though you could leave it at 7 over 4 and you say change 7 degrees for every 4 hours, we kind of want to know what it is for every 1 hour. So that's why we're making it a decimal, and it's still like rise over run. It's still temperature over hours. Questions on that? Okay. So then table 7, if I need to find the average rate of change between noon and midnight, what coordinates do I need?
0, 18, and 12.
Okay, great. So noon is 0 hours since noon, midnight is 12 hours since noon. Those are the values we're using. Make one of them x1, y1, the other x2, y2, and plug it into your average rate of change formula, which I recommend rewriting and if you haven't done that. The way that I labeled it, table 8, the way that I labeled it, what would be my y2? Table 9, what would be my y1? Table 1, what would be my x2? And table 2, what would be my x1? Okay, great. So, I mean, you could have labeled it differently, but however you label it, you need to stay consistent. You should see the numbers from the same coordinate on top of each other. Then you need it right with a y on top, of course. Class with 7 minus 18. What is 12 minus 0? And I'm for sure going to use a calculator for that. And side note, like, probably should just use a calculator once you have it in the fraction, honestly. That way you're just letting it do the order of operation for you. So 7 minus 18 over 12 minus 0. X2 minus 1 for x2 minus 1. That is right. And then just to compare, here's these, and I already subtracted it in my head, so whatever you like better. If you're trying to make mistakes in your subtraction, then this. But this is a decimal, it rounds to. Make sure when you take your test that you read it and round it accordingly. Let's just go to 2 decimal spots because it didn't say otherwise. So that's about -0.92. So So if my average rate of change is negative 0.92, what does that tell you about how the temperature changed? So everyone needs to be engaged in this. Stop looking at your screens. We're at our final answer. This is my average rate of change. When it's negative, what does that say about the change? It decreased. So to interpret it, you'd say it decreased by an average of 0.92 degrees Fahrenheit for every 1 hour. Okay, when you're saying, because this could come up on some of your assessments, if you had to fill in blanks, you would say it decreased by 0.92 degrees per hour. You wouldn't say it decreased by negative 0.92. If it asks what the average rate of change is, you would just say negative 0.92. But if it's saying like, oh, it decreased by this, like we won't say it decreased by negative 0.92. Say it decreased by 0.92. Okay, questions, comments, concerns? All right, so be prepared to do an average rate of change problem on every test for the rest of the year. New situation. So we have, oh, well, let's go back to the warm up because we never actually talked about who was correct. So raise your hand if you think that May was correct from the warm up. Raise your hand if you think that Tyler was correct from the warm up. Okay, so Tyler was correct. And when you do the math of it, again, it's y2 minus y1 over x2 minus x1. But we know, like, for tables, calculating average rate of change, you could also just look at what's the change in y divided by the change in x. Tyler had said 4 p.m. to 6 p.m. So when I look at this change, let me make that table more condensed. We were comparing 4, 6, and 10. And here are those y values. All right, this is from the warm-up in case you're confused. What's the change from 25 to 17? And it went down 8, so I'm going to put negative 8. What's the change from 4 to 6? Okay, so again, I need you guys looking up here. When I put that as the change in y divided by change in x, that's negative 8 over 2, which simplifies to what? So Tyler 4 is correct, and you could say, because on average, the temperature changed, and I'm abbreviating, or I'll even say decreased by, so you know how it changed. By 4 degrees Fahrenheit each hour. That's the average. Not saying that that's actually how it changed per hour, because you can see now, as you look at the more specific table, it changed by 2 degrees and it changed by 5 degrees. But when you average that, it's 4. When you compare to May, she said that this was a more drastic drop. What's the change from 17 to 8? And we're going down, so I'm going to put negative 9. What's the change from 6 to 10? So that is still you doing y2 minus y1 over x2 minus x1. It's just like another way of looking at it. Negative 4 over 9. or not, oh, I said that backwards, -9/4 is 2.25. So her statement changed by 2.25 degrees, which is less than 4. Right, questions? I feel like we don't care, should we not even bother with the last example? Give plenty your homework. If that's totally fine, if you already got it, great. But if not, like, we got a whole nother example. So raise your hand if you think you're good. Raise your hand if you need some extra help. All right, then that decides it. I mean, it really is just this formula. So if you need help, by all means, let me know. We have 30 minutes to work on your practice, so I would expect it to be done. No phones, no headphones, just practice and study guide. Go ahead.
Okay, so one thing I do want to point out, I mean, I'm completing the notes because I changed some stuff from what I have in Schoology, so it'll be posted in there, everything with all the explanations and the math showing. So like for number one on this one, you really do kind of have to calculate it because if I'm comparing these two portions, they kind of look like they're increasing about the same. Like one is definitely higher than the other, but like the average rate of change is actually really close to each other. Like they're only 0.1 away from each other. So mathematically, you would have to do that one to say which one changed faster. Okay. But then when we're asking about in number two, which one grew more quickly between 1900 and 2000? I don't need to do the math because visually I can tell California grew way faster. They started at about the same, and then California's gets way steeper. And that's what I said in my explanation. So if it asks for a specific average rate of change, then yeah, you need to provide that decimal. If it doesn't and it just says which one grew more quickly and you could tell without having to do the math, then by all means. Any questions, make sure that you ask. You got plenty of time. I shouldn't see that nobody was able to turn it in this 30 minutes you have to do like just a few questions. Okay.